Okay, ladies and gentlemen, this video is obviously on linear quadratic systems, and just like the previous video, we're going to solve a couple of these problems as quickly and efficiently as possible. And this is one of those essential concepts when you get into the upper level math like IM3, trig pre-calc. Okay, but anyways, instead of rambling on, let's get to the problem. Here's a couple problems that was presented to me by a former student, and let's start with problem 3 here. Okay, now getting straight to the point here, notice I have a linear equation there, y equals mx plus b format. Here I have a quadratic that's in standard form, and I'm trying to figure out where they cross each other. I'm trying to find their solution set. Okay, so how do we solve that? Well, notice how they're both already equal to y. Follow the red. If they're both equal to y, logically, whatever is equal to y in both equations must equal each other. And that's how we're going to approach it. We're going to substitute literally one of the y's in for the other y. We call that the substitution method. And so here's what we got. Notice I took the x squared plus 5x plus 6, and because it equals y, and negative x plus 1 also equals y, they must equal each other. So here is my equation basically I'm going to solve. Okay? So, first thing I'm going to do, because it is a quadratic, I'm going to make sure it equals 0. So I'm going to go ahead and add x to both sides. And if you will permit me to do 2 steps in one, I'm also going to minus 1 from both sides. And let's see what we end up with. We end up with x squared plus 6x, because 5 plus 1 is 6, right? And 6 minus 1 is 5, equal to 0, because x minus x and 1 minus 1 is 0. So now that I have it equal to 0, I can solve this. Now normally, guys, I would factor this and I'd be done in a matter of a few seconds. But I notice some of you are struggling with factoring. So we're going to approach this with the quadratic formula. A equals 1, B equals 6, C equals 5. Again, 1, 6, 5, correct? 1, 6, and 5. Okay, so you should have the quadratic formula memorized. I'm just going to say it out loud. We're going to take the negative of the b plus or minus square root. We're going to take the b and square it. Minus 4 times the a times the c. Be careful with any negatives in there. All over 2 times the a. Continuing on, I know the negative of 6 is negative 6. I know 2 times 1 is 2. Now comes the radical part. This right here, again, I'm just going to go ahead and do it old school without a calculator. I know 6 squared is 36, so let me just jot down my notes here. And I know that right there is minus 20. So the whole radical in there is 16. And what is the square root of 16? 4, right? Again, the whole thing in the radical became 16. Square root of 16 is 4. Okay, I'm almost done. So if you look down the bottom of my screen here, I'm just going to take negative 6, add 4, and divide by 2. And I'm going to take negative 6 minus 4 and divide by 2. And so I'm going to get 4 minus 6 is negative 2 over 2, which is negative 1. And of course, negative 10 divided by 2 is negative 5. So I'm going to have 2 answers like I usually do. Okay? So I'm not done quite yet. These guys are, after all, my x values, right? I also need the y values to come up with the points. So going back to the original problem, follow the green right here. Let me clean up my mess first. We know the linear equation, we know y has to be negative x plus 1, right? So if y equals negative x plus 1, let's plug in the negative 1. Negative of negative 1 plus 1, that's 1 plus 1, which is 2. So one ordered pair is negative 1, 2. Okay, let's take negative 5 and plug it in. Negative of negative 5 plus 1, that's 5 plus 1, which is 6. So my other ordered pair is negative 5, 6. Negative 5, 6. So let's go back to the original problem. And notice they did not have both answers there, guys. But there is my negative 5, 6. Okay? So anyways, here, what I'd like you to do now, guys, is try problem 4. Okay? Try this problem 4 right now. Pause the video here, in other words. Okay? Try it yourself and then see my solution. Okay? Try it yourself, then see my solution. So on the count of 3, 1, 2, 3, pause it. Okay, guys, so hopefully you tried number 4. Here's basically what you should have come up with. Now follow the light blue here. Notice how I set them both equal to 0, did I not? Because they both equaled y, correct? And then notice right here, I went ahead and did 2 steps at 1. I went ahead to make it equal 0. I minus the 3x. I added the 15, correct? And then I solved right here using the quadratic formula. Again, if you can factor though, guys, if you can factor, you can get the answers much quicker. Okay? But that's another video. And after I did the quadratic formula, notice I came up with my x's of 5 and negative 1. And what I proceeded to do over here and here is plug in the 5 and negative 1. And if you look in the bottom of my screen here, I came up with both solutions, 5, 0, and negative 1 was negative 18. If we go back to our original problem, notice negative 1, negative 18 is right there, correct? And notice right here, guys, follow the green, see how they try to trick you. They flip the 5 and the 0 and they mix in the negative 1 in there. So don't fall for those distractors. Okay, guys? Be careful about that. But anyways, so the answer for number 4 was D. Correct? Negative 1, negative 18. And the answer again for problem 3 was C. Okay? Negative 5 and 6. So guys, I hope that by watching this video you'll understand better how to solve linear quadratic systems. Until next time, bye.